Hi, I'm Professor Marilu Tineva, and I'm here to discuss to you the topic on equations in one variable. I hope that at the end of this lesson, you will be able to identify the type of equation in one variable, solve the equation in one variable, and check the solution. My discussion has 5 parts, and they will be presented in the following order, starting with a motivation. Then, we will have the different types of equations in one variable, such as the linear equations, quadratic equations, rational equations, equations involving radicals. Now, let's begin by playing a simple game. Are you ready? I want you to think of a number to put in the box so that the left-hand side of the equality symbol is the same as the right-hand side. So, blank minus 5 equals 23. I know you have done this in your elementary days, so you can do it. That's right. The answer is 28. Let's try more. Blank square plus 4 equals 68. What should be in the box? That's correct. The answer is 8 because 8 squared equals 64, and 64 plus 4 gives 68. And 68 equals 68 is a true statement. Yay! With the same problem, can you think of another number to put in the box? Yes, negative 8 can also make the equality true because the square of negative 8 is also equal to 64, and 64 plus 8 equals 68, resulting to 68 equals 68, which is a true statement. Yay! I know you love challenges. So how about this one? This time we have a fraction. You are right. The answer is 2 because 7 plus 1 half gives 14 plus 1 all over 2, and indeed 15 over 2 equals 15 over 2 is a true statement. What if more and more boxes appear in the problem? That means the problem becomes more complicated, and it would be hard to do trial and error, right? But let us not worry, because fortunately, mathematics provides a method or a technique to make such problems easy, like a piece of cake. All we have to do is to replace the boxes by the variable, say x. Then the qualities in the previous slides become the following equations. The first one becomes x minus 5 equals 23. The second one becomes x squared plus 4 equals 68. And the third one is 7 plus 1 over x equals 15 over 2. These open sentences are examples of equations in one variable. What is an equation then? We define an equation as any open sentence that asserts equality of two mathematical expressions. And any value of the variable that can make the equation true is called a solution. And we refer the set of all solutions as the solution set. To solve an equation is to find all its solutions or its solution set. From our game earlier, we have guessed that the desired value is 28, and this value is called the solution of the equation x minus 5 equals 23. So, the solution set is the set containing 28, written inside a pair of braces. So you see, these things are not new to you. Let's enjoy learning more. Now, we learned the techniques to solve the simplest type of equations called linear equations. We define a linear equation in one variable as an equation that can be written in the form ax plus b equals 0, where a and b are real numbers with a not equal to 0. It is also called linear because the degree of the variable in x is 1. Some examples are 2x minus 28 equals 0, and this is in standard form. Another example in variable y, and another example in variable t. We are guided by the following steps in solving linear equations in one variable. Step 1 is to simplify until you get the standard form of the linear equation. Step 2 is to use the addition property of equality. Step 3 is using the multiplication property of equality. And finally, check the value you get. For example, solve the given linear equation. Take note that this is not in standard form. So let's simplify first. From the original equation, we apply the addition property of equality by adding negative 23 to both sides. Then, combine like terms and we should get 0 on the right-hand side. And this equation is now in standard form. Clearly, it is linear. By the addition property of equality again, we can add both sides of the equation by positive 28. The inverse of the constant term, negative 28, and we get this. We can omit this line here to shorten the process. Then, we multiply both sides by 1/2 or divide by 2. And we get the value x equal to 14. Then, we check the value we get. We substitute x equal to 14 to the original equation. Then, we get this. And so we end up with a true statement, which means that 14 is a solution. Therefore, the solution set is a set containing 14. Note that there is no other value other than 14 that can make the equation true. An equation which is true only for some values of the variable is called a conditional equation. So we say that the given equation is a conditional equation. Now, example 2. Solve this equation. This equation contains a parenthesis, and we need to remove this parenthesis. So let's simplify. Bring down the first term 3 on the left-hand side, then we apply the distributive property of multiplication over addition, that is, negative 3 times 2, which is negative 6, negative 3 times negative x is positive 3x. And then transpose all the terms of the right-hand side to the left-hand side to make the right-hand side 0. And don't forget to change the sign. Remember that transpose means applying the addition property of equality. Combining like terms, we now have the standard form. Then, divide both sides by 2 and that's it. From the standard form, transpose the constant term to the right-hand side. Then, both sides will be divided by 2. And that's it. This time, our value of x is a fraction. That's okay. Again, we need to check the value of x before writing the solution set. If we plug in 5/2 to the given equation, the result is a true statement. Therefore, 5/2 is in the solution set. How about this equation? If we try to express this in standard form, notice that all terms cancel out on both sides. So we didn't get a value of x, unlike the previous examples. Instead, we obtain an equation 0 equals to 0, which is in fact a true statement. If this is the case, then the solution set is the set of all real numbers. So the given equation is called an identity equation. Here's our last example of solving linear equations. If you try to express this in standard form, we will have this result. On the left-hand side, x is cancelled out again, but the right-hand side is not. We ended up getting 0 equal to 11, which is a false statement. So, what does it mean? It means that the equation has no solutions, and the solution set is the empty set, or null set, denoted by this symbol. In this case, the given equation is called an inconsistent equation. Now, it's your time. Try this by your own Here you are provided with the answers for you to check your work. Have fun! Let us proceed to quadratic equations in one variable. An equation in the variable x of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers with a not equal to 0, is called a quadratic equation in standard form. There are several methods in solving quadratic equations, but here we focus only to two methods, and these are by factoring and by using the quadratic formula. First, solving quadratic equations by factoring. Here are the suggested steps. Step 1, write equation in standard form. Step 2, factor the left-hand side of the equation in step 1. Then, set each factor in step 2 equal to 0, solve for the value of the equation, and then check for the values you get. Now, we will illustrate the steps using example 1. This example is already in standard form. So proceeding to step 2, we want to factor out the left-hand side. By now, you must have mastered factoring polynomials. The factors of the left-hand side are x plus 5 and x plus 3. Then, setting each of these factors by 0, then we have x plus 5 equals 0 or x plus 3 equals 0. And notice that these equations are linear. Solving this equation, then we get x equal to negative 5 or x equal to negative 3. Now, we check each of these values independently. When x is equal to negative 5, the original equation becomes this and this and this. So we ended up with a true statement 0 equal to 0. Then we check the other value x equal to negative 3. Plugging this into the original equation, we have the following. And we still end up with a true statement 0 equal to 0. So therefore, the solution set is the set containing these two values, negative 5 and negative 3. Another example is solving the quadratic equation 2x squared plus 3x equal to 9. Notice that this equation is not in standard form. So simplifying this into standard form, we have this equation. And clearly, factoring out the left-hand side of the equation gives the factors 2x minus 3 and x plus 3. Then, setting each of these factors by 0, we have 2x minus 3 equal to 0 or x plus 3 equals to 0. And these equations are now linear. Solving this linear equation becomes x equal to 3 halves or x equal to negative 3. By checking these two values, you can see that these two values satisfy the equation, and therefore the solution set contains negative 3 and 3 halves. The next one is solving quadratic equations by using the quadratic formula. We will state the quadratic formula. The solutions of ax squared plus bx plus c equals 0, where a is not equal to 0, are given by x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, solving quadratic equation by the quadratic formula consists the following steps. First, write the equation in standard form. Step 2, identify the values of a, b, and c in step 1. Step 3, substitute the values in step 2 in the quadratic formula. Then, simplify the right-hand side in step 3. And most importantly, we check the values that we get. So, for example 3, solve this equation by using the quadratic formula. From the given equation, we need to transform this into its standard form by adding the left hand and the right hand side negative 9. So we get this equation. Now, the values for a, b, and c are respectively 2 from the coefficient of x squared, b is 3 from the coefficient of x, and c is negative 9, the constant term. Let us substitute these values a, b, and c in the quadratic formula. So we have, and then simplifying, we get this x, negative 3 plus or minus 9 all over 4. And we have two possible solutions, and these are x1 is equal to negative 3 plus 9 over all over 4 because we are taking the addition, and this is equal to 3 halves. The other possible solution is x sub 2, and this is by subtracting 9. That is, negative 3 minus 9 all over 4 is equal to negative 12 over 4, and simplifying this becomes negative 3. And upon checking these two values, x1 and x2, you will see that these values satisfy the equation, and therefore the solution set contains the numbers negative 3 and 3 halves. Consider example 4. Solve this equation by using the quadratic formula. Again, we need to transform the given equation into its standard form. So we simplified here. Then we identify the values for a, b, and c. And notice that a is equal to 0, b is equal to negative 2, and c the constant term negative 1. Then, plugging in these values a, b, and c to the quadratic formula, we have the following. And so our x is equal to 2 plus or minus 2 is square root of 3 all over 4. Simplifying this x becomes 1 plus or minus square root of 3 all over 2. And we have these two values of possible values of x. We have the x1 when we add up square root of 3. That is 1 plus square root of 3 all over 2. And the other value for x is 1 minus square root of 3 all over 2. Upon checking by substituting these two values in the original equation, you notice that these values x1 and x2 satisfy the equation. Thus, the solution set contains these two values of x1 and x2. Now, try this one. This is for you to work out. Continuing to our discussion, we will tackle now about rational equations. Recall that a rational expression is a fraction whose numerator and denominator are both polynomial expressions. So we define a rational equation as an equation containing at least one rational expression where the variable appears in at least one of the denominators. Some examples are the following. Before we solve rational equations, let us first understand how to find the LCD or least common denominator of the rational equations. Finding the LCD is identifying an expression that contains the highest power of all of the factors in all of the denominators. Examples. Example. 1 over x is equal to 4 over 2x plus 1. The LCD of this equation is the product or the expression x times 2x plus 1. Another example, note that we have a common factor in the left-hand side and on the right-hand side. So the LCD is the product of the square of x plus 2, because this common factor x plus 2, we will take in the LCD the highest power. So we have x plus 2 squared. And the other factor, x minus 1. So we have this LCD as the product of these two factors. Solving rational expressions involves only two steps. Step 1. Factor all denominators in the equation. Step 2. Multiply both sides of the equation by the least common denominator or LCD to eliminate all denominators. After doing these two steps, the rational expression is reduced to either linear or quadratic equation. So, solve each of these accordingly. And remember to reject any value that makes the denominator 0 in the original equation. For example, solve this rational equation. In this example, all denominators are already in factored form. So let us proceed to multiplying both sides by the LCD. And the LCD is x times 2x plus 1. Then we cancel out x on the left-hand side and we cancel out 2x plus 1 on the right-hand side. Then the left-hand side becomes 2x plus 1 and the right-hand side becomes 4x. And this equation here is linear. Solving this linear equation, we get the value x equal to 1/2. And notice that upon checking this value, and note that when x is substituted to every denominator, then the denominator is not 0. Therefore, the solution set is the set containing 1/2. Example 2. Solve this equation. First, we need to factor out the denominator x squared minus 4 on the right-hand side. And the factors are x plus 2 times x minus 2. Then, we get the LCD. And the LCD is the expression x plus 2 times x minus 2. Multiplying this both sides, we get this equation. And simplifying, we get a quadratic equation. X squared plus x minus 2 equal to 0, which is in standard form. So, solving quadratic equations, by factoring, we have the left-hand side factors of x plus 2 and x minus 1. Therefore, our values of x are -2, or we have x equal to 1. Setting each of these factors by 0, we get x equal to -2 or x equal to 1. Notice that when we substitute x equal to -2 to the original equation, the first denominator becomes 0. That is, -2 plus 2 equals to 0. So, we need to reject this value x equal to -2 because it makes the denominator 0. And denominator and a fraction of denominator 0 is not defined. Notice also that when x is equal to 1, substituting this to the original equation satisfies the equation. Therefore, the solution set is the set containing 1. Now, the last but not the least type of equations we are dealing with is the equations containing radicals, particularly of index 2. We are guided with the following steps. Step 1 is to isolate the radical on one side of the equation. Step 2, square both sides of the equation, and the resulting equation is either linear or quadratic. Then solve the resulting equation. And remember, reject any value that does not satisfy the original equation. So, example 1. Solve this equation. First step, isolate the square root on the left-hand side. So we have this. -5 is transposed to the right-hand side. So let us remember, in transposing, the sign becomes opposite. Then we square both sides. And then squaring each of the side, the left-hand side becomes 8x plus 1. And the right-hand side becomes 25. And take note that this equation is linear. Solving this linear equation would give us an x value of 24/8, which is simplified as x equal to 3. Then, checking the value we get, x equal to 3 to the original equation, we have the following. So, we ended up with an equation 10, which is not equal to the right-hand side 0. Therefore, we need to reject x equal to 3. And therefore, the solution set is an empty set. Example 2. Solve the given radical equation. So again, we isolate the square root on the right-hand side. So again, we isolate the square root on the left-hand side, giving us this equation. So that means positive x is transposed to the right-hand side, and the sign becomes negative x. The left-hand side becomes 2x minus 3, and the right-hand side becomes x minus 6x plus x squared. Simplifying this, the first step is isolate the square root on the left-hand side, so we have this. That means positive x will be transposed to the other side, which becomes negative x. Then, squaring both sides, we get on the left-hand side 2x minus 3 and on the right side 9 minus 6x plus x squared. Note that this equation is quadratic. And simplifying into its standard form, we get x squared minus 8x plus 12. Solving this quadratic equation by factoring, we have the factors on the left-hand side, x minus 2 and x minus 6. Therefore, we have the values of x equal to 2 or x equal to 6. So we check again these two values. Substituting each to the original equation, we have the following. So we ended up on equation 3 equal to 3, which is a true statement. So we may say that x must be in the solution set. When x is equal to 6, we have the following, and we ended up a statement 9 not equal to 3. So therefore, we must reject the value x equal to 6. So the solution set contains the value 2 only. So this is now your time. Try all of these equations and you are given again with the solution set. And try to check your work if you get these solutions. And that would be all. Thank you for listening. Bye!